Hello everyone, here we are going to discuss a little more about VLSI, which is kind of the strongest pillar of our semiconductor industry. Now, what is VLSI? As you have already seen in the classification of IC lecture, it is the process of integrating 10,000 to 100,000 transistors on a single silicon semiconductor chip. It is actually a technology that involves packing more and more logic devices such as your transistor onto our ICs. What is the main aim here? The main aim is to create your microchips that are increasingly powerful, that are compact, and that are also energy efficient. This is the successor of LSI. I hope you remember what is SSI, what is LSI, where we are typically using hundreds of transistors. So in LSI we were using hundreds of transistors, but here we went a step ahead and we are using millions of transistors, right? Now, you might feel that this is a new term, but it is not. The term actually originated around 1970s. Now, the remarkable advancement in our electronic industries due to the ongoing growth in our VLSI technology, which is why this is very, very important for us to know that what exactly it means. And like I said, it is a technology where we are trying to pack more and more transistor onto an IC, which we have also seen in our Moore's law. Now, let's talk about the advantages of this technology. So the advantages of our VLSI technology is, number one is the increased functionality. Now VLSI allows packing millions and billions of transistors onto a single chip. I also told you about the term ULSI in a previous lecture. I hope you remember that. But we are kind of sticking with the term VLSI only. And this enables the creation of complex electronic system with advanced functionality. For example, your microprocessor, microchip, and also your system on chip design. So what we are doing, we're trying to achieve increased functionality with the help of VLSI. Second is size reduction. Now VLSI technology enables the miniaturization of our electronic devices by integrating numerous components onto a single chip. And this size reduction is crucial for making electronic devices smaller, and we're also trying to make it lighter and more portable. Third one would be improved performance. Now, with the integration of more components on a chip, the signal paths have become shorter, which is also leading to faster operation and improved performance. Now, additionally, VLSI technology also allows us to optimize the circuit design and the layout, right? Which is further improving our performance more and more. Next one is lower power consumption. Now VLSI design, they can be optimized for lower power consumption through techniques. For example, your power gating, we have voltage scaling, we also have a technology called clock gating. Now reduced power consumption is critical. Why it is critical? Because we want to extend the battery life, especially for the portable devices, right? And we also want to minimize heat dissipation. Next would be cost effectiveness and reliability. Now, of course, with the initial design and fabrication of our VLSI chips, it definitely involves a significant investment, and mass production can lead to the economies of scale, right? It results in lower per unit cost. I hope you understand my point. Now when the per unit cost is lowering, it is definitely becoming more and more cost effective for us. And this cost effectiveness and this reliability is the one which is actually making our VLSI technology more accessible for a wide range of application, from your consumer electronics to also your industrial components and industrial systems. So I hope now you have a fairly good idea about VLSI and many more terms. So I'll see you in the next lecture. We are going to learn so much more. Till then, bye.